Okay, so we're going to be talking about sed. Sed stands for stream editor, but we'll see that when we get to it. Okay, so it's another regular expression tool. Let me go down a tiny bit more. There we go. All right, so our objectives are to use sed to transform text. So it's a filter that's for the transforming of text. And you give sed a bunch of commands so that it can do its transformations, and they are Q, P, I, A, C, D, and S. And then we'll talk about how do we specify what lines these commands should apply to by line addressing, and we can address lines by line numbers or by regular expressions. And then finally, we'll have back references in these things, just like we can have in grep. All right, so sed, the stream editor. What do we got? So sed is a multi-purpose tool that can do a whole bunch of text manipulation. So you can make sed behave like head, you can make it behave like tail, you can make it behave like grep, and you can make it behave like all other things. Well, not all other things. It's derived from this program called ed, which was the original Unix text editor, which eventually got replaced with Emacs and Vi. But it can work on streams, so input streams. So it behaves like a filter. It can read from standard in, and then it can write to standard out. Or just like other filters, it can read files and then output to standard out. So it's going to read in some lines of text, it's going to apply some transformations, and then it's going to output the text after those transformations. So the usage is like most Unix filters. We have sed the command itself, and then optionally, whatever options you want to give to sed. And then you give it a command. So the form of a command is an address followed by an action. Okay, so this guy would be the first positional argument is the command that you give it, whereas all these guys are options. They all have hyphens in front of them. And then if you give it any more positional arguments, it's assuming you mean read from files with those names. But that's optional. If you don't give a file, it reads from standard in, so just like grep. So here's an example of a sed command. It says sed, and then in quotes, because I don't want the shell to interpret that $, because it's not a meta character intended for the shell, it's intended for sed. We've got an address part, which we'll get into and explain in detail when we need to, but it says starting on line 1 until the end of the file, and then it has the action part in here. So this action is the S action, which stands for substitute. So it's going to do a substitution, and we'll talk more about how S works when we need to. Oh, and also, it's going to read input from this file called foo. Partit, you're in the chat twice. How exciting. Okay. So the options for sed, there's a lot of them. These are the ones that I wanted to highlight. -E lets you use multiple commands given to sed. So here, I'm only giving it one. It's this entire thing in the single quotes. If I can grab, I guess I can't. All of that's a single sed command. If you want to give a single instance of sed more than one command, you can specify them with -E. So just like in grep, we can give grep multiple patterns, which are ORed, by saying -e. So in this case, we've got a command for sed, and it's got some kind of addressing part, which I'll just talk about later. The command that's going to be applied is W, which stands for write, and then it says forms.html. So what it's going to do is all the lines that match this address are going to be written into this file called forms.html. All right, the next one's lowercase f. It says take its instructions from a file. So just like lowercase f in grep, if you've got a lot of patterns you want to give to grep, instead of putting them all on the command line, you can put them in a file and then tell grep to read that file for its commands. Likewise for sed, if you've got a lot of sed commands, you can tell it to read them from a file rather than having to put them all on the command line. Okay. Also like grep, we have the -E right here. And capital E enables extended regular expressions. So like grep, the default is basic regular expressions. If you want to use the features of an extended regular expression, you have to tell it with the -E option. So the same as grep. Okay, now we got one that's different from grep, -N. So in grep, -N means print line numbers. But in sed, it means suppress printing of every line. Like that's literally what it says in the docs. But you can think of it as like saying don't print. So the default action for sed is after it's done all of the commands you tell it to do. So up here, I've told it to do 3 different things. After it's done all 3 of these things to every input line, by default, it will then print that line on standard out. Okay, so if you don't want it to do that, you can say -n. So it'll just not print by default. Okay, I got a table here of the often used commands in sed. So these are the ones that I use on a fairly regular basis. So S is by far the most frequently used, but I've had case or cause to use all of these things at one point or another. There are a lot more that I'm not listing here. You can see there's N, lowercase n, and then there's a little note, see also capital N, capital P, and capital D. Right, and there's also a command G that does something, and there's just tons and tons and tons of them. But these are the ones I wanted to focus on because these are the ones that I use on a regular basis. So again, sed is going to read a bunch of lines from an input. It's going to apply some commands, and this is the list of commands. Okay, so here's some quick examples before we get into the full details of everything. Actually, no, let's do these guys. Let's do one of each. So the first command, S, is substitute. And we're going to have another slide on substitute because substitute can actually take quite a few options, and they're relevant to substitute. So it says print the sequence up to 100. So let's do that. Get rid of this, and then I'll just clear this. Okay, so we're going to print the sequence 100. So that's going to print out the numbers 1 to 100 to standard out. And then here it says sed S09G. So this one's a little weird. I probably should have used Y. But basically, this is going to treat the input just like a TR command. And what it's going to do is it says substitute 09. So it's going to replace all the zeros with 9s. And then I'll ignore this G for now, and we'll say exactly what it means when we learn the substitute command in detail. Okay, so let's do the outputs from, what was it? Let's not, yeah, 1 to 100, sure, we'll do it. And then I do a sed, and we're going to do a substitution from 0 to 9, so all the zeros and 9s get replaced. And then the G flag. You can see, well, let's start right here. This was originally 90, but it got replaced. So the 0 got replaced with a 9, so that's why it says 99. This was originally 100, but each of the zeros got replaced with a 9. So this command right there is just like, well, it's exactly the same. So I think it's exactly the same. I got to be careful when I say exactly. So it's the same as this command, tr, translate all of the zeros into 9s. All right, so same output. And in fact, if we want to be 100% sure it's the same output, let's do a process substitution and a diff. So there, we're going to do the sequence up to 100, pipe that guy into sed, and I'm going to tell sed to do a substitution 0 to 9 globally. And then we'll close off the process substitution, and no output and a 0 exit status. So that means those two were identical. Okay, and you might wonder, well, why would you use sed instead of tr? Tr is much more lightweight because we can put regular expressions into these things, and we can also address lines by regular expression. But I'll save that until we get to it. If you, well, there should be sound. I'm showing that I'm putting out sound. And yeah, you would have to refresh D2L to see the announcement. People have come and gone, so they've seen it. All right, the next command is Q. So normally sed will run, it reads every line of input on standard in until it sees end of transmission or end of file. Likewise, if you give it file names, it'll read those files and it will apply the commands to every line as appropriate. But if you want it to stop early and just quit, you can do that with Q. So I'm going to run, again, sequence. Let's just go from 1 to 10, like so. And then I'll pipe that into sed. And then I'll give it the command to Q. So I quote everything by habit. So that's why these are quoted. They didn't have to be, though, because there's no meta characters there. Okay, so sequence did the output 1 through 10. That got piped into sed, and then sed was given this command 2q. So sed first reads the line 1, and then it says, okay, does this command apply to that line? It says no, because it says it only applies to line 2. So then it outputs the 1 and then goes to the next line. So it reads the next line, which is a 2, and then here it says sed 2q. Well, this is line 2, so it applies. So then sed terminates, but before it terminates, it prints out the 2. So that's why sequence had the outputs 1 through 10, but sed read line 1, read line 2, and then it quit. Tried to pipe grep grep, and I entered in a bunch of 3-character words and 4-character words. Okay, I'll come back to that after we talk about sed, because, well, no, I'll do it right now. I'm going to say, I don't believe you, okay, because this is actually not something that should happen. Okay, so ASDF. Oh, interesting. What happened there? Hold on, Control-Shift-D. Is it just sitting in a buffer? Yeah, it was just sitting in the buffer. So it was sitting in this pipe. You had to tell it end of input to make it do the output. Okay, let's go back to the next command. Okay, the next command is D for delete, and it's going to delete the line. All right. So Control-Shift-D to send it. Yeah, thank you, Partit. Okay, so here we got 2Q. Let's change that guy to 2D. All right, so here it says line 2 delete. So there's the line 1, and there's no line 2, and then we got 3 through 10. So those were allowed to proceed. Only line 2 was deleted because I said on line 2 delete that line. And the next guy is print. So you can see I've used the -n option here. I'm going to first run it without the dash. No, we'll run it with the -n first, and then we'll look at it without. Let's do sequence 3. I'm going to pipe that guy into sed -n, and it's going to say 2p. So the address portion is the 2, and the command is the p, and the p stands for print. Right, so I ran this sed with -n. So what it first did was it read line 1. Actually, I'll run sequence again so I can trace it. Oops, whatever. All right, so there is my original 1, 2, and 3, and then pipe through sed. So sed reads the first line, and then it looks at its list of commands and see if any of them applies. This command only applies to line 2, so nothing applies, and it goes to the next line. Normally, when it goes on to the next line, it would have printed this line. But here, because I said -n, it didn't. So this suppresses the standard behavior of printing. Then it reads the next line, 2. Okay, and then it looks in its list of commands, and it has a command that applies to line 2. So it applies that command, and it prints it. So it puts the 2 on standard out. Okay, then it goes to the next line. And the next line is a 3. This command doesn't apply, and since I said -n, it does not print it. Okay. So now let's try running it without the -n. This will be kind of fun. So there we go. Sequence 3, sed 2p. All right, so what it does is it reads line 1, and then no commands apply to line 1, so it goes to the next line. But before it goes to the next line, it prints that line. Then it reads line 2. And it finds on line 2 it's supposed to print something. So that's what the first 2 is. It's printing it from this p right there. All right, and then that's all the commands. So it goes to the next line, which will be the 3. But as it goes to the next line, it also prints the line that it just read, because that's a default behavior. That's why we've got 2 2s. And then it reads the 3. There are no commands that apply to the 3, so it goes to the next line. But before it does, it prints out the 3, and then that's the end of file. Okay, so if we take the 2 away, then this p will be applied to every line. So we're going to duplicate every line. So we got 1, 1, 2, 2, 3, 3. Okay, the next one is an n, lowercase n. So this is a kind of funny one. So it stands for next. So at this point, I think I got to talk about the internals of how sed works. So let's just run this and see it first. So sequence 6, sed n, semicolon d. Okay, seq 6. So that's obviously 1 through 6, and let's do it again so the 1's not knocked over. 1 through 6, and then that gets piped into sed, and it says n semicolon d. All right, first thing to notice, there's a semicolon here. So there's actually two commands. The first command is next. The second command is delete. Okay, let's run it and see what it does. It says 135. All right, so I'm going to trace this and show you exactly what it was doing. Where is it? New file. We'll put it over on the right because these inputs are pretty small. No, not on top, on the right. Yeah, sure, right there. Okay. So my input was 1, 2, 3, 4, 5, 6, like that. All right, so that's the output from seq. Then sed runs, and there's no address, so this applies to every line. So it's going to run both of these commands for every line. Okay, so the first thing it does is it reads in line 1. So it reads this guy right there, the 1. But the command is n, and n tells it go to the next line. All right, so it does that, but as it goes to the next line, it also prints the 1, because I didn't say -n. The next line is line 2, but the command that's left to be executed is the d. So then it deletes line 2. And then it goes to the next line, and there's the 2's been deleted, so there's nothing to output. It reads the 3, and it goes back and it says, okay, the command is n, so I go to the next line, but as it goes to the next line, it outputs the 3, and then the next command it's given is d, so it deletes line 4. And then it goes to the next line, which is a 5. The command is n, so it goes to the next line, and when doing so, it outputs the 5, and then it sees the 6, and the command that's left is delete, so it deletes the 6. So that's what happens there. Okay, I'm going to add one level of detail to tell you exactly how this thing works. So in sed, there's this thing called the pattern space. Okay, and you can think of the pattern space as a variable. It's just when it reads a line, it goes into the pattern space. There's also another variable called the hold space, which we won't talk about. So the command G and G operate on the hold space, and I think H and H do as well. I try to avoid using it because it makes things kind of confusing. Right? If you give sed a file instead of a stream, will it delete the line from the file or just the output? So just the output. So that's a very good question. So here I'm going to save this file, and I guess I'll overwrite foo. Yes. Okay. Reload, sure. Whatever. So then let us cat foo. So there is, okay. There's foo 1 through 6. Okay. So what I'm going to do is I'm going to run sed. And I'm going to give sed the exact same command, n semicolon d. All right, that. And then I'm going to tell it foo. So it reads from foo, but it still outputs to standard out. Right, and now if I was to cat foo, you can see that foo is unchanged. If you want it to change foo, you can do that. You give it the -I option. That stands for in place. So that means it's going to, well, the intention is it's going to change the file foo in place. So in place means there's a file foo, I'm going to tell you to do some stuff, and if I say in place, it means actually do it to foo, right? Don't just output it on standard out. So if I run that, you can see foo changed. It's now 135. Okay. So I'm going to put those guys back so we can talk about the pattern space. Thank you for the question, because that's something that trips a lot of students up. They'll run sed and they think it changes the file, but it actually doesn't. I would discourage you from using this unless you really, really mean it. Just have your output to standard out and then use a pipeline like we normally would. Okay, so I'm going to run this again. I guess I can just do this. Okay, so that's going to be my command. So we have this thing called pattern space. I think that's what it's called. So what set's going to do is it's going to open the file foo for reading, and it's going to first read this line 1. And what it's going to do is it then puts the 1 into the pattern space, like that. Okay, then its command is n. So that's going to move sed to be on the next line, but when it goes to the next line, it's going to print the pattern space. So that's why there's a 1 in the output. So this will be our output. Okay. N does two things, actually. It moves sed to the next line and reads it. So it's going to take this 2, puts it into the pattern space. So first thing it did was go down here. As it did that, it printed the pattern space, because that's the default behavior, unless you say -n. Then it reads this line, and it places that into the pattern space, like that. Okay, so then it's done both of the commands n and d. So then it has to, oh sorry, I didn't apply d yet. It's just done the n. So then it does d. Well, d means delete the line. So this line gets deleted. It's not just an empty line, it's actually like null. There is no line there anymore. Once it's done the d, then it's done all the commands it had to do. So it then goes down to the next line. Okay, as it goes to the next line, it prints the pattern space, but the pattern space is null, so there's no output. Then it reads the 3. The 3 goes into the pattern space. The command that's applied to the 3 is n, so it goes down to the next line, and the default behavior is when it goes to the next line, it's going to print the output, so we get the 3 on the output. Then it reads the 4, because that's what n does. It puts it into the pattern space. Then it applies the next command that's supposed to be applied, which is d, so that's a delete, so that gets replaced with null again. And then it's done all of its commands. So it goes to the next line, which is the 5. Okay, so it reads the 5, and it puts that into the pattern space. Okay, then the command that's applied to the 5 is the n. So it's going to go to the next line, but before it does, it prints the 5. Then it goes down here. It reads that line, puts it in the pattern space. And then the n is now complete, but the next thing it says to do is delete. So we replace the 6 with null. Okay, then it's done all of the commands it's supposed to do, and it's consumed up to here on the input. So it goes to the next line, but the next line is the end of file. So it's done. That's why we have the output 135. And I'll just run it again to show that. Hey, where's the 3? What happened? Oh, I didn't save it. That's why. So we've got to get that out of there. Save it. And then run it again. There we go, 135. So that's how it works. It's operating on this thing called the pattern space. Okay, the next command is for grouping. So this sed command says sed, by default, don't output. So this means every time you go to the next line, don't print the pattern space. Okay. Then there's an address. This is a regular expression address. We'll learn about these in more detail when we need to. But it says every line that contains an A, do these commands. All right, so we've got these commands. Up here, we didn't have to put them in brackets because it applied to every line. Down here, they're placed in brackets because they're both applied to lines that start with, or sorry, contain an A. So here it says a substitute BCG, substitute X, Y. And we'll talk more about what those do, but it's going to apply both of those commands to every line that contains an A. We also could have changed, well, I'll save that for later. Next command is Y. It stands for transliterate because clearly there's a Y in there. It's the same as the TR command. So here, what are we going to do? It says sed y abcde 0, 1, 2, 3, 5. So if this was TR, it would see this and say, replace all the A's with 0s, replace all the B's with 1s, replace all the C's with 2s, replace all the D's with 3s, and replace all the E's with 5s. Okay. So you might wonder, why would you do this instead of tr? Tr is much more lightweight, and if this is all that it was doing, I would say use tr. But we're going to see why we might want to use sed once we get into more complicated things. So the next one is A, and it stands for append. And what it's going to do is it's going to put a line after the line that it's applied to. S and Y don't do the same thing. Y is just like TR. It's one character at a time. But S, you can actually match patterns. So I'll save that until I get there. But it applies to patterns, not just individual characters. So sequence 3 piped to sed A 1000. Let's not do 1000. Let's just do ABC. So we'll do sequence 3. So we have our output 1, 2, 3. And again, I wish it didn't do that. There we go. We're going to pipe that into a sed. And the sed, the command I'm going to give it is an A and 1000. No, not 1000. I said I'd do ABC. There we go. So let's trace that. So the input was 1, 2, 3. Okay, the pattern space is this guy there. All right, so sed A, ABC. So A means append. So what it does is it reads the first line, okay, it puts it into the pattern space, and then the command is A, ABC. So I believe, not 100% certain, how could I find this out? Not sure. I think it puts ABC in the pattern space like that. Let's find out. I'm going to learn something. I want to run 2 sed commands, which I haven't talked about. This is for my interest now. Okay, E, and then we're going to run another sed on that. Oops, another sed on that. And it's going to say substitute B's with X's. What do we get? No, it did not. So that's not in the pattern space. Okay, good to know. All right, so it looks like what it did is it reads the 1 into the pattern space, and then it's going to advance to the next line. So it outputs the pattern space, which is just the 1, but it also has a command that says ABC. All right, so what it's going to do is after the 1 is output, it then puts ABC. And then it does the same for 2 and 3. Okay, but it looks like this ABC does not go into the pattern space, because if it did, that guy should have modified it. Or would it? Is there a capital S? Let me check one more thing. I am very curious now. No, there's no capital S. Okay. So, why is the A simply ignored? What do you mean? A wasn't ignored. It was the command, A. And the A stands for append. So as it read each line and outputted each line, it appended this line after it. So we got 1 ABC, 2 ABC, 3 ABC. So let's do another one. The next command is going to be I for insert. So let's do it. We're going to go here, and we're going to insert. So if append puts a line after, insert puts a line before. So here it says, do the sequence 1, 2, 3, pipe that into sed, and sed has been told to insert ABC. So for every line that it reads, before it prints that line, it's going to print out ABC. So we got ABC1, ABC2, ABC3. And now, I am super curious, so I'm going to try the S again. So you guys don't have to worry about this. We're going to do an S, and we're going to substitute all the B's for X's. Yeah, it's not in the pattern space. Okay, that's neat. I learned something. Don't worry about it. This says, for every time you print something out, before you print it, print this line. And the other one, for every time you print something out, before you print it, print that one. So that's A and I. So there's a command on the assignment, sorry, a question on the assignment where I ask you to do something like this, but I explicitly say don't use S. So you can use an S to kind of make it do this, and I don't want you to do that. I want you to use A and I. because I think I say you're not allowed to use S as the command. So A is append, I is insert, C stands for change. And what this is going to do is it's going to change the line. So let's see how it works. We'll do sequence up to 5, like that. We'll take that, we'll pipe it into a sed, and I'm going to tell sed to change the line to redacted. So there, oh, what did I do wrong? Oh, where'd my sequence go? Okay, whatever. Sed, change it into redacted. There we go. So it reads the line into the pattern space. So it read the 1 into the pattern space. And then it's going to output that when it goes to the next line, but I've said change it to redacted. So we don't see the 1, it gets replaced with this in the output. Okay, if we combine that with an address, let's give it a 3 for an address here. Then it says only apply this, whoops, sorry, there. Only apply this on the third line. So we got the 1 and the 2, and then on the third line is changed, or sorry, the third line is changed to say redacted. One more command. It's the equals. Equals means print the line number. Okay, so let's do sed. Actually, let's do a printf. Did I say printf? Nope. Printf. Printf. There we go. I want you to output a character, and then a new line, and then a string, and then a new line, and then another character. So present C. Okay, and a new line. Okay, and what I want it to print is an A, followed by the string X, Y, Z, followed by the string, I don't know, P. So there's our input that's going to go into sed. I'll move this over so it all fits. Oops. Okay, I'll fix that in a moment. There we go. That goes down to there. Okay, so I'm going to pipe that into a sed, and the command I'm going to give sed is just equals. So this is going to be applied to every line, the equals command. Okay, so here you can see it printed a 1 and then the A. It printed a 2 and then the XYZ, and it printed a 3 and then the P. So trace that. We got 1, 2, 3, and here we have the pattern space, and here we have the output. Okay, so first thing it does is it reads the line that contains a 1. Sorry. Or sorry, that wasn't the input. The input was, what was it? A, XYZ. Let's get rid of that 1. And then P. So that was our input. So it reads a line that contains an A, and that goes into the pattern space. Okay, but before it does anything with the pattern space, it sees it's given the command equals. So that command means output the line number. So we're on line 1. We just read line 1, so it puts the 1. Okay, then it's done its commands, so it's going to move to the next line of input. But when it moves to the next line of input, it prints out whatever's in the pattern space, which is an A. Then it reads that next line, so XYZ goes into the pattern space. The command is equals, so it's going to print out the line number, so 2. And then it's done all of its commands, so it's going to go to the next input line. But before it does that, it prints out whatever's in the pattern space, so XYZ. So it gets to the next line. It's going to read the input into the pattern space, so there's the P in the pattern space. The command is equals, so it outputs the line number, which is 3. And then it goes to the next line, but the default behavior again is to print whatever is in the pattern space, so it prints the P. And then the next line is the end of file, so that's when it's done. That is tracing the equals. So those are the commands that I use on a fairly regular basis. So let's look at some other examples of sed. This guy says sed a // and it's reading from a file. Okay. So I think I need another file. We'll save this guy foo. We're going to copy Actually, no, we're not. Get rid of this. Okay, we got A, X, Y, Z, P. Okay. Oh, I need to save foo. Then I'm going to copy that into bar. Oops, I gotta say foo. Foo, bar. There we go. Copy foo into bar. There is foo. We need bar. And we'll put that below foo. Like that. And scroll him up. There we go. Okay. So our input's at the top. And then we're going to have our pattern space for sed right there. And then we'll have beneath it the output. Okay. So the command I'm going to give it is we're going to, I'm going to cat foo because I feel more comfortable with cats up front. Actually, I'll do a redirect. I need to get into this habit. We're going to take our input from foo. Remember, that is the redirector for standard in. Okay. Then I'm going to run sed. And I'm going to tell sed, well, let's just replace it with an equals right now so we see the same kind of output. Okay, 1A, 2, XYZ, 3P, right? So the shell sees this and it says, okay, you're redirecting foo into standard in, and then here's the command sed equals. And then sed runs, it sees it was only given one argument, so it knows it's going to have to read from standard in, which the shell is providing from that redirect. Okay, it looks funny, but it's the same as this. Exactly the same as this, except I flipped the order, which you're allowed to do with redirects. Okay, so let's trace, oh yeah, that's not the one we're doing. We are doing this, A backslash backslash. All right. If you run an append and then give it 2 backslashes, sed knows that that means a new line character. So it's going to double space this input. Don't ask me why. I think way deep in the documentation it might explain why, but it's going to interpret this to mean a blank line, so just a new line character. So I've told it append a new line. So what does it do? Well, it reads the first line, A, places that into the pattern space. Okay. Then it's done its operations, but it keeps track that it's supposed to append this thing right there. And it outputs the A because that's what's in the pattern space. And then after it outputs the A, it appends whatever I told it to, which was a new line. So it goes down one extra line in the output. Okay, then it reads XYZ, like that. And it keeps track that it's supposed to append a new line. It's done all the commands, so it outputs the pattern space, and then it appends a new line. Whoops, sorry, I should be one down. Then it reads in the P. The P goes into the pattern space. It's done, so it outputs the P, and then it appends, hold on, then it appends a new line. And that was the output. We've got an A at the top, then a blank, then the XYZ, then a blank, then a P, then a blank, and we're done. So that's the output there. Oops, including this new line. So for some bizarro reason, this double backslash thing means a new line character. Okay, looks like I lost my connectivity briefly. Whatevs. All right, this next example, well, we've seen stuff like this already. This isn't the address part, but we haven't explained how they work, so let's ignore it. Same with this one. So by far, the most frequently used command in sed is substitution, this S thing. So you would give it a command, just like the form we described above. So the command part can have an address and then the actual command. But S actually takes 3 parameters. So the first parameter is expression 1. So this can be a regular expression. The second parameter is expression 2. So this is also something kind of like a regular expression, but not exactly. And then the third parameter is called flags, but these are the flags to the S. So really, these are the 2 arguments you give to S, and then you can set a bunch of flags. Actually, you can only set one. No, you can set more than one. Yeah. Okay. So here's a description. Expression 1 is replaced with expression 2. So that's why it's called substitute. We're going to find expression 1 and we're going to substitute expression 2 in its place. And that's going to be applied to all lines that match the address, which we haven't talked about yet. So let's ignore that. Let's ignore that too. All right, so if you run an S with no flags, only the first occurrence on the line of this expression. Oh my God, Partit. Oh no, it's not you. It was Young Fei. Young Fei, turn your microphone off. All right. What were we doing? All right. If there are no flags specified to the S, it's only going to apply the substitution to the first match of expression 1. Okay. If the flag is set to G, then it's going to replace all occurrences. So that stands for global. There's other flags like 2. Okay, whatever. This is too theoretic. Let's actually run it. Actually, is the next slide that? Yeah, here we go. Okay. So here's an example. I'm going to have 2 lines of input, though, not just 1. So my lines of input are going to be ABC, ABC, and then CBA, CBA. So just reversed. Okay, and we're going to do the same kind of deal in bar. We're going to have our pattern space and then our output. Okay. So the first command, we're going to do the same thing. We're going to redirect foo into sed, and I'm going to tell sed every line do a substitution, and it says replace. What did I tell it to do? I think it's A and X. Yeah, A and X. So A/X/. Okay, so we'll run it and we'll see what it does. And hey, I didn't save foo. Let's try that again. All right. So there's no flags given to sed. So by default, it's going to only replace the first thing that matches this pattern. So this is actually a pattern. That's a regular expression. It just happens to be a single character though. So let's change it. Let's make it interesting. Let's do B question mark. Okay, but remember this is now an extended regular expression because it has a question mark in it. So I'm going to have to tell sed that's an extended regular expression and run it, and it says it's angry because I put the space on the wrong side. Way to go. Okay, right there. All right, so what did it do? Well, originally we had an AB right there and an AB right there. Okay, and then the next one has an A but not followed by a B, and an A but not followed by a B. But I didn't give it any flags, so it's only going to apply this to the first thing that matches this pattern on each line. So I'm going to trace it. What it does is it takes ABC, 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 puts it into the pattern space, and I'm actually going to write the command above as well so that we have it for reference. Our command was SAB question mark X, like that. All right, so this substitution is applied to the pattern space. So what it's going to do is it looks into the pattern space to find the first thing that matches AB question mark. Ooh, that was some massive thunder. Very loud. Okay, or a major explosion, I don't know. So this part matches the AB question mark. And what it's going to do is it's going to substitute the X in its place, so that gets replaced. But because I didn't give it any flags, it only does it to the first one, so this one doesn't get changed. So now this is the contents of the pattern space, so it goes down to the next line, but before it does, it prints the pattern space, XCABC. All right, now the next one is read into the pattern space, like that. And it's CBA, CBA. We're looking for AB question mark. Well, there it is right there. That's an A followed by 0 Bs, which question mark will take 0 things. So that's the first thing that matched. Okay, that's going to replace that with X. But because I didn't give it any flags, it only does it to the first one. So this is kind of weird. You'd think by default it would apply it to everything, but sed is a very old tool, and it doesn't. It only applies it to the first one. Okay, so that's my pattern space. It's done all its commands, so it goes to the next line, but before it does, it outputs CBX CBA. So it output the pattern space, and then it's done. So that's why we got that output. Any questions about that one? Next thing I'm going to do is apply a G, the global flag. Okay, so there's the G. Now, okay, so there's quite a bit of thunder. If I lose power, I'll keep recording and just talk to myself, I guess, and then post it on YouTube when I'm able to. I'm on a laptop. But my router will probably go down, which means you guys won't be able to watch anymore. All right, so here's our first input, ABC, ABC. So I'm going to paste that into the pattern space. Okay, and then it says AB question mark. Well, there's AB question mark. We're substituting X. But because I gave it the G flag, it's going to apply this globally. So it's going to keep looking on the line. So there's the next thing that matches AB question mark, and it substitutes that with the next. Okay, so then that's it. It's done. It's command. So it's going to go to the next line and print the pattern space. So XC, XC. And then it reads the next line, which goes into the pattern space. Okay, and then it's going to apply this command to it because this command has no address on it, so it applies it to all lines. It's going to look for the first thing that matches AB question mark. Okay, again, right there, that matches AB question mark, sorry, the A. Replaces that with the X, and because it says global, it goes to the next thing that matches, which is that one, and replaces that with an X. Then it's done its operations, so it's going to go to the next line, but before it does, it prints out the pattern space. And then the next line is end of file, so that's it. It's done. So let's run it. There we go. Put a G there. Whoops, it's got to be, well, it doesn't have to be in the quote, but it makes more sense if it is. There we go. So we get the output XC, and then CBX, CBX. So the difference was whether or not this global flag was set. Okay, I'm going to show you one more. Let's run it with a 2 instead. All right, so the G is going to become the 2, and the 2 means only do this to the second occurrence. So get rid of our output. I'm going to grab our first line, put it into the pattern space. So first thing it does is it looks for the first occurrence. Okay, there's the first occurrence, but I said only do this operation to the second occurrence, so it doesn't change that. Then it finds the second occurrence right there, and it's going to replace that with an X. Okay, then it's done its operations, so it's going to output that. And then it reads the next line and puts it into the pattern space. Okay, it looks for the first match. There it is. But I said only do this to the second match, so it doesn't do anything. Finds the second match, substitutes the X, goes to the next line, and prints the pattern space. And then the next line is end of file, so that's the end. Let's see that. So ABCXC, and CBA, CBX. Okay, so that is the substitute command in a nutshell. So it's going to find patterns, and it's either going to replace the first occurrence or all of the occurrences on the line. Remember, this is per line. It's not globally in the entire file. It will be global in the entire file because it'll read every line unless you tell it not to with a Q or something. But the G applies per line. So, all right. Let's go back to slides. Oh, madness. Right, so this is demonstrating that commands in sed can be chained together. Okay, so I'm going to go back to just AX for this one, because it makes a little more sense. What were my two commands? A, B, G, and then BC. Okay, do that. A, then a B. That's not a B. B, G. And then the next command was substitute B, C, like that. Okay, so I'll trace this and I'll do it step by step. But before I do that, let's get rid of the output and let's get rid of the pattern space. Okay, read the first line and put it into the pattern space, right there. Okay, now the first command that was given, oh yeah, those commands were separated by a semicolon because they're on the same line. Right? I think if you put them on separate lines, you don't need to separate them with semicolons, but this is telling sed this is a different command now. So we got substitute ABG. So globally, replace the A's with B's. So there's an A, replaces it with a B, and because it was global, it does it to all of them, so that becomes a B. Okay, then we have the next command, which is applied to what's still in the pattern space. So then it says, oh, that should be an S. Sorry. There we go. Substitute B with C, but only the first one, because there's no G. Well, there's the first B, so that becomes a C. And then it's done its commands, so it goes to the next line, but before it goes to the next line, it outputs the pattern space. So there's our first line of output. Okay, next it reads this line, it reads this line. Okay, and puts it into the pattern space. It applies the first command, replace all, because of the G, of the A's with B's. So replace that guy with a B, replace that guy with a B. Then the next command says replace only the first B with a C. Okay, well there's the first B. Replace it with a C. Okay. And that should be the output. So let's see if it is. So we're going to take from foo. We're going to run a sed. And the sed is first going to have a substitution of A with B globally, semicolon. The second command is substitute, whoops, did I hit S twice? Yes, I did. And we're going to do, hey, go back. There we go. Substitute the first B with the C. Okay, run it. And we get CBC, BBC, so CBC, BBC. And then CCB, CBB, CCB, CBB. All right, so when you give sed more than one command, they chain together just like filters. It'll apply the first one, and then it'll apply the next one, and then apply the next one, etc., etc., etc. Okay. So this is where the Y command would actually be useful. So let's imagine I had to do some operations. I'll do a substitution for some pattern. It doesn't matter what it is, like this. And we'll just say I do it globally. And then I want to do a translate. So whatever the first set is, whatever the second set is. And then I'm going to repeat this kind of pattern. So to every line, I'm going to apply all 18 of those commands. Right, I can do this with a single instance of sed. Right, I can run one sed and I can tell it, here's your first command, here's your second command, here's your third command, here's your fourth command. But if I was to use tr for the translate part, then I'd have to run a sed to do the substitution and pipe it into a tr. And then take the output of that tr and pipe it into another sed and pipe that into a tr. So I'd end up with 18 processes running. But if I did this with the Y in sed, it would only be one sed process running, and it would do all of this. So much less overhead if you have something like this, because you can run a single sed instance to do all of these things rather than launching 18 separate processes. Any questions about the way substitution works or the way that things chain together? Okay. So next, we're going to talk about addressing, finally. We can address things either by line number or regular expression. So line numbers are just line numbers. You put the number. Regular expressions are just basic regular expressions, unless you say -e and then they're extended. But they appear in between forward slashes, so just like in Perl and JavaScript. So we're going to bracket our regular expressions with forward slashes. So this says the lines that start with FROM colon, capital F, because it is still case sensitive. All right, we can also negate an address with an exclamation mark. So I'll see examples of that. So here are some simple ones with line numbers. So sed 3q, we already saw that kind of example. And it was, I believe, it was, we'll do a sequence up to 4. Whatever, we'll go to 5. We'll live dangerously. Okay, 1, 2, 3, 4, 5. And oops, I gotta go to the next line. No? There we go, sequence 5. I'll pipe that into sed, and I'll say sed 3q. So when it gets to line 3, it's going to print line 3. So print whatever was in the pattern space, and then it will quit. And that's what we see. So it stopped reading at that point. It didn't read line 4 or 5. So that's an address like that. Another example here, sed-n 2p. So remember, -n suppresses the behavior of printing the pattern space. And the p command explicitly prints the pattern space. So let's run it. Let's do a sequence, again, up to 5. We'll pipe that into a sed, and I'll tell sed, oops, sorry, I gotta say -n of 2p. So by default, don't print the pattern space, but on line 2, I want you to print whatever's in the pattern space. So there we get only the 2 is output. And if we take away the -n, just to demonstrate that again, okay. Now here, I'll trace this for you quickly. The pattern space, it reads the 1, and then it asks, do any of my commands apply to line 1? No, I only have one command and it only applies to line 2. So it's done, but what it's going to do is, as it goes to the next line, it's going to print the 1, because that's the default behavior, because I didn't say -n. With the -n, it doesn't print the 1. That's the difference. It doesn't print the pattern space. Then it reads line 2. Line 2 goes into the pattern space, and then it says, I have a command that applies to line 2, and it's print. So I'm going to print the 2, because that's what's in the pattern space. And then I'm going to go to the next line, but my default behavior is to print whatever is in the pattern space when I go to the next line. So I'm going to do that. That's why we had 2 recurrences of the 2. And then the 3 goes into the pattern space. This command does not apply because it's not on line 2. So it goes to the next line, but in going to the next line, it prints the 3, right? Etc. So it's just, I've told it, when you get to line 2, print it. But by default, it's printing every line as well. So that's why we have 2 recurrences of the 2. Okay, to specify the last line, you say $. So $sign is the address of the last line. So let's run this. Sequence up to 5, pipe it into sed. And the address part is $, and the command is p. Okay. So what happened, I didn't say -n, so it prints every line anyways, but then when it got to the last line, it did the print command. That's what the first 5 is. And then when it moved on to the what would be the next line, but it was actually the end of file character, it did its default print action. So let's run that with a -n, see what happens if it doesn't print by default. -n. There we go, so just the 5. So on the last line, print, and that's it. So it's like the same as tail -1. Right. You can also negate address. So here it says the last line negated. So every line except for the last line. So let's run it. We'll do a sequence to 5. Pipe that guy into sed. And then we'll do a -n. So the default is not to print the lines that are in the pattern space. And then I'm going to say on the last line, negated p. So this address here, the $not, that's going to match every line except for the last line. So every line except for the last line, print. There we have 1, 2, 3, 4. Right, and those numbers only occurred once because I used the -n. So lines can be specified by number, and the last line is a $, and we can negate things with the exclamation mark. Right. So just individual lines is not super useful, but we can also give ranges. So the way to specify a range in sed is comma. So it says 9, 11. So that's lines 9 through 11 inclusive. So 9, 10, and 11 will be printed. So let's do a sequence. We'll tell it to go to 20, and then I'll pipe that into a sed. And then I'll tell sed the address part is 9, 11. So lines 9 through 11. And the command is p. I want you to print. Oh, I forgot to say -n. That's easy to fix. -n, there we go. So there it is, 9, 10, and 11. I'm going to make a note. So there's optionally a separator between the address and the command. So these two are the same. Okay, so that's specifying a range. You specify it with a comma. Okay, we can combine that with telling it, hey, I'm giving you multiple commands. So we're using -e to say I'm giving more than one command. I could have also used a semicolon to separate them. Let's try it both ways. 1, 2, and 7, 9. Okay, so we'll do a sequence 20, pipe that into a sed. And then I'm going to tell sed, let's do it with the e's first. We'll do -e, and it was, let's do 2 to 4. Print, and then another -e, and let's do, I don't know, 9 to 11 again, print. And I forgot to say -n again. Oh man, I gotta deal with the lag for this now. Okay. So it reads all the input lines. It's not printing whatever is in the pattern space because I suppressed that. And then it gets to line 2, and I've got a command that says on lines 2 through 4, print. So it prints 2, 3, and 4. Right, and then it keeps reading stuff, and this no longer applies because we're past line 4 until we get to line 9. Then this applies. So lines 9 through 11 print. So 9, 10, and 11. Okay, so a range with comma. This guy says 3, comma, $. So it says starting on line 3 until the end of the file, inclusive, print the line. Okay, so the next example here is a step. So you can specify a step parameter to addresses. So here it says sed-n 1 tilde 3p. So what this says is we're going to print beginning on line 1 every third line. Right, so lines 1, line 4, line 7, line 10, etc. So print every third line starting from line 1. So let's do it. We're going to do a sequence to 20. Then we'll give it a sed. -n, I finally remembered. 1 tilde 3p. And there we go. So every third line starting at line 1. So we got 1, 4, 7, 10, 13, 16, and 19. Okay. One more notation, the plus. So this is for specifying a range, so it also requires the comma. But instead of giving like a hard endpoint, so instead of saying 6, 8, I've said 6 and then the next 2 lines. So it'll be line 6, line 7, and line 8. So line 6 plus 2 more, print. So that's weird. Like you might think, why didn't I just put the 8? Because we're going to be able to combine these things with other forms of addressing that'll be more useful. Okay, so we'll do a sequence up to 20 again, I guess. Pipe that into a sed. And I'm going to tell sed on line 6 and the next 2 lines, I want you to print. And again, I forgot to say -n. So this is a G and U tool, so I know I can put it at the end. It's bad form. There we go. So we got 6, 7, 8. And the 6 is only pushed over because of my prompt. So that guy right there, starting on line 6, for on line 6 plus the next 2 lines, print that line. So 6, 7, 8. So those are the way to address things. We got ranges, we got steps, and we've got a number of following lines. So that's with line numbers. We can also address things with regular expressions. So here is an example. It's a practical example. It says, read my mailbox in my home directory. So my email inbox might be stored here on certain machines. And it says, all of the lines that start with from, print them. So it's going to go through my inbox, and every line that's in there that starts with from, it's going to be printed. So it's basically going to print the sender of all the emails I've received, or any other line that starts with from, like if it was in the message body. All right, so we can specify addresses with the forward slashes. Okay. We can use any form of regular expression. There's our Wilco example again. And this guy here, we're looking for all the variations of spelling O'Brien, at least in lowercase. Right, now you'll notice there's a double quote here because O'Brien itself contains a single quote. So I could have used a single quote, but then I would have to do the weird single quote escaping thing, which is single quote backslash single quote single quote. Don't worry if that didn't make sense. Instead of dealing with that, I just decided to put it all in double quotes instead. Right, and then this one is just Lennon. I don't know why that one's special. Okay, so all those things that we learned about line numbers for ranges also apply to regular expressions. So here it says, starting on a line that contains Johnson until you encounter a line that contains Lightfoot, print. So it's going to read all of the inputs, and then when it finds a line that contains Johnson, it's going to apply the print operation until it finds a line that contains Lightfoot. But remember, the range is inclusive. So it's still going to print the line that has Lightfoot. So let's try to demonstrate this. We'll go, let's do that. And I mean, these regular expressions are going to look a little weird, but I'll still do them. Oh, I need a quote there. Okay, I'm going to say all the lines that contain the number 1. Let's not do 1, actually. Yeah, let's do 1. Until it encounters a line with a 2, I want it to print. And of course, I forgot the -n. -n? Nope. Okay, there we go. And, oh, I thought I fixed that. There we go. Okay. So, first line of input contains a 1, so it's going to start printing things until it gets to a line that contains a 2. The next line contained a 2, so it stopped printing things. It still prints that line, though, because this is an inclusive range. So that's why 3, 4, 5, 6, 7, 8, 9 don't get printed. The next line it encounters contains a 1, so it's going to start printing things. Right, until it encounters a line that contains a 2. Well, that line contained a 2, so it printed that line and then it stopped printing things, but the very next line started, or has a 1 again, so it starts printing things again until it gets to a line that contains a 2. Let's have this thing go to 30. Okay, there we go. So 1 and 2, and then all of these contain a 1, so they all get printed. And then the next line contains a 2, so it stops printing at that line. But then the next line contains a 1 again, so it starts printing. Let's change these guys. The 1 is not helpful. Let's make it, I don't know, let's make it 2 and 3. Oops, I missed. 2 and 3. Okey-doke. So there we go. A line that contained a 2 is going to start printing. A line that contains a 3, it stops printing. A line that contains a 2, it starts printing. A line that contains a 3, it stops. Okay, then a line that contains a 2 starts printing. There's a line that contained a 3, so it stopped, but the very next line contained a 2, so it starts printing again, and it goes until it encountered the line that contains a 3, so it stopped. Let's make it more exciting. Replace it with a 4. Okay, so here is the 2. It's going to start printing, or it actually started printing way back here. Oh no, this one was there. That's where it started. And it's printing all of this. Then it encountered a line that contains a 3, so it stops. That's why there's no 31, but then it finds another line that starts with a 2, so it starts printing, and then the very next line started with a 3, so it stopped printing, and that's why we don't see any of the other 30s. There is some weirdness about if these things occur on the same line. Don't worry about it. I'm not going to test you on that. All right, here's where we've mixed a regular expression with a line number. So it says starting on line 1, until you encounter a line that contains woodcock, print. So let's do something like that. So, well, we've got this string right there. Let's just throw a couple more in, foo and bar, save them. Okay, then we're going to redirect foo into a sed, and I guess I'll tell it that starting on line 2 until you encounter a line that contains, I don't know, OO, which is not too exciting. So let's put one more line in here. Let's just put a line that has an X. I want you to print, and I forgot the dash n. I'll just tack it on the end. It's bad form, but I don't want to deal with a lag. Okay, so this was line 2, CBA, CBA. It prints it, because that's when it starts printing. And it keeps printing until it encounters the line that contains the 2 O's, and that's when it stopped. Okay, we can also negate, just like we could with numbers. This says, find me the lines that contain the substring secret, and then negate that. So this is going to apply to all of the lines except for the ones that contain secret. So print them. So it's going to print every line that does not contain the pattern secret. We could also use the tilde and the plus if we want. So let's do that. What do we got? Let's look for the pattern CB. So we're going to do foo, pipe that into a sed, and we're going to tell sed to look for the pattern CB. And then I'll have it go every other line, like that. Print. Oh, I missed the comma. No, there shouldn't be a comma. Does that not work? Oh, maybe that doesn't work. Okay, I lied. That doesn't work. Let's see if the plus does. The plus should, because it still has a comma there. Okay, comma, plus. And CB, why didn't that work? Maybe it doesn't work with patterns. Maybe that's why it's not in the slides. I expect it to work. Nope. All right, I was mistaken. It doesn't work. Let's make sure it's doing anything at all. Dumb. There shouldn't be a pipe there. That's why. Okay. Oh, and I forgot the dash n. All right, so this line had the CB, and then it prints the next 2 lines with the plus. Okay. So the next ones are a little more involved. I'm going to ignore this example. We'll come back. Sed-e 1i. So remember I is insert, and it says line 1. So it's going to place a line before line 1. And that's going to be this thing here. So that line is going to be inserted before the first line. Then down here it says the last line, append. So this line is going to be placed after the last line. And this does the same thing, except it is modifying a file in place. I've told it -i, so it's going to actually make the changes to foo.html, not just output to standard out. Actually, it won't output to standard out. It'll just modify the file. Okay, we got another example. Sed-es compute calculate g. So it's going to replace all occurrences of the substring compute with calculate. And then it says s computer host g. So I'm going to trace this one. So let's say that computers compute, like that. Nope, not computers, just computers compute. Yeah, I think that'll demonstrate what I want. So my commands, these first two, are substitution, compute, calculate, -g. Oh, and I missed the t. Calculate -g, like that. And also substitute computer with host, like that. Okay, so the pattern space will be here, and then the output will be here. Okay. So we've got computers compute. So we're going to read that line and then place it into the pattern space. Then it's going to apply the first command. So we got this first command here, substitute compute calculate. Okay, well, there's a compute right there, so it's going to replace it with calculate. And then there's another compute. Because it's doing global, it'll replace that one too. So the output will be calculators calculate. Okay. So let us run this. We're going to redirect from foo into sed, and then we're going to have a big command. The first part of it will be this, right there. Insert. Okay, then the next command, they were -e's on the slide, I think, but I'll use semicolons so I don't have to go back. And then that one goes there. So when it runs, oh, I forgot to save. There we go. When it runs, we can see we've got calculators calculate. So that was predicted. But the intent was computer should have been replaced with host. So the intended way to fix this is you flip the order. So there, I'm going to put that. That guy goes there. So now if that's our command, when it runs this, it reads this line into the pattern space. And it says replace the computer with host. So there's computer. It becomes host. And then the next command says replace compute with calculate. So there's the compute. So we replace that with calculate, like that. And then because there's no -n, it's going to print whatever is in the pattern space. So that goes right there. Okay, so I'll type it out from scratch because I'll have to replace a lot. Redirect the foo into a sed, and we're going to first take this command. Actually, I think I could just paste them both because they're on separate lines. We'll find out soon enough. There we go, like that. And it says hosts calculate. Okay. The next one says, how do you sort a file that's double spaced and still preserve the double spacing? Okay, so we're going to start this off. We're going to start, let's do it with a Y, and then an X, and then a Z. And that line, or that file is double spaced, like that. Okay. So we can do this with sed. We'll start off with one way that works, but not always. So first things first, I'm going to redirect foo into an occurrence of, what do I want to do? Let's give it to sed first. Okay, did I type that or not? Something is not right. I cannot type. Okay, that worked. Okay, save it. Control C a couple of times. All right, there we go. So we're going to redirect a foo into a sed, and I'm going to tell sed that I would like to, for all the blank lines, I want to delete them. That's what this says. So we're going to say dollars, or up arrow $, delete. So if I run that, then my output should just be yxz, which it is. Ignore that the y is indented. That's just some weird prompt thing. Then I can sort that. And I get xyz, but I wanted to preserve the double spacing. So what I can do for that is we'll do a pipe, and we'll pipe that into another sed. And this sed, I'm going to tell it to append a blank line after every line. So there we go. We got the x, the y, and the z. So we got it sorted and double spaced. Okay, this has a problem though. Let's say that right here there was a blank line, like in the actual input there was a blank line. So you can see right here, that's going to strip it out. So that is not what we want. We would like to have kept that blank line. Right, so there it's gone. Well, there's no easy way to fix it with this form, so we're going to have to do something else. But we can easily do something else. We can use sed to print every other line, no problem. So we'll do that. I'm going to redirect foo into a sed, and I'm going to tell sed for line 1 and then a step of 2. So every other line I want you to print. And I forgot to say -n. There we go, y, x, blank, z. Those were my content lines. Okay, alternatively, I could have used the madness of n semicolon d. Oh, I missed the n. Actually, I hit the comma instead. I got a lot of lag here. N semicolon d, slash d semicolon n. There we go. Should do it. Nope, missed. Go there. Yep. All right, n semicolon d. There we go, every other line. So either of those works fine. Take that, pipe it into sort. It's going to move the blank line to the top because blank comes before anything else. Let's do that again where my prompt did not mess it up. Whoops, missed. There it is. Okay, so we got the blank line at the top. They're now in sorted order. I can then take that, pipe it into sed, and tell sed to append a blank line after every line. And there we go. So here's our blank content line, right where the mouse cursor is, and then that's the double spacing line. And then the x and a space, and a y and a space, and a z and a space. So we took a double-spaced input file, sorted it, and then outputted double-spaced. But we kept the blank line that was content because it was on line 5. These were the spacing lines 4 and 6, but I wanted to keep 5. Any questions about any of those examples? Okay. We can also use back references instead, just like we can in grep. So there's 2 ways to refer to things. We have the ampersand, which is new, that wasn't in grep. And what that refers to is the part of the substitution that matched. So here is the substitution rule. It says, find me words that begin with a D. So all words that begin with a D, and it's all because there's a G there. So all words that begin with a D replace with whatever matched this pattern a space, and then whatever matched the pattern again. So it's going to duplicate all words that start with a D. So our input is dogs don't do that. And this word here, D-O-N, that's a word because N to apostrophe is a word transition. All right, so let's trace it. So I'll take the input, dogs don't do that, and we'll put it into our input file. Yeah, and then I gotta fix it. Okay. And of course, why did one of them get a space but not the others? Okay, so the command was, I'll have to do this from memory, substitute word boundary D \W star. So all words that begin with a D, sorry, words that begin with a D, we're going to replace it with whatever matched, a space, and whatever matched, and we're going to do it globally, so all of them. That's the command. We're going to take the pattern space, dogs don't do that, we'll put it, sorry, that's the input line, we'll put it into the pattern space, and let me fix this quotation mark so it's not stylized. Okay, and then we're going to apply this command. So first, it looks for something that matches this pattern. Well, there's a word boundary, there's a D, and then there's a whole bunch of word characters. So dogs matches the pattern. So it's going to replace dogs with whatever it says to replace it with over here. It says ampersand, ampersand. So you'll note I have dogs selected. So ampersand gets replaced with what I have selected, and that's the same thing that matched the pattern right here. Okay, so I'm going to replace that occurrence of dogs. So let me copy it into the clipboard and delete it, so it's gone, and it's going to be replaced with ampersand space ampersand, but ampersand will be what matched. So there's the first one, and there's the second one. And because it's global, it continues. So there's the next word that matches. So replace it with what matched, a space, and what match. And there's the third one. Replace it with what matched, a space, and what matched. And that's the output. Dogs, dogs, don't do that. And that's what we have here. Dogs, don't do that. So you can use this in a basic regular expression, because this is something sed does. This is like a meta character for sed. So if you just have to replace the entire match with something, you can get away with using ampersand. If you need to use capture groups, like we were doing in grep, then you still have these back references with the numeric identifier for the capture group. Okay, so we've got he'll be there, and our command is swapping the first and second letter of a two-letter word. So let's have a look. He'll be there. Okay, we're going to replace that with the command that says substitute word boundary, and then a capture group word character, and then the next capture group word character, and then a word boundary. We're going to replace that with \2, \1 globally. Okay, so we're going to put this, grab it, put it into the pattern space. Okay, then it's going to try to do some matches. So there's a word boundary, and that's a word character, and that's a word character, and that's a word boundary. So that, oops, that shouldn't be an N, that should be a B. So that matches the pattern I'm looking for, this thing. But in addition to that, I have two capture groups. So I'm going to denote those as little variables down here, number 1 and number 2. Okay, so capture group 1 took the capital H. Okay, and capture group 2 took the lowercase e. All right, so that one matched with that one. And then this one, not the B, this one matched with that one. All right, and then it says replace that with whatever's in capture group 2 and whatever's in capture group 1. So this HE gets replaced with what's in capture group 2, which is the E, and then what's in capture group 1, which is the H. Then it looks for the next match. There's the next match right there. So that gets an L in capture group 1 and an L in capture group 2. But that gets replaced with whatever is in capture group 2, which is an L, and then whatever's in capture group 1, which is an L. Okay, there's the next match, because it's a two-letter word, or two-word character word, I should say. And then in the first capture group is the B. Stop that. And in the second capture group is the E. Okay, so there's the thing that matched. That gets replaced with 2, 1. So 2 is the E, and 1 is the B. So we get this, EH apostrophe LL EB there. And that's what shows here, EH apostrophe LL EB there. The next one says that it's supposed to swap the second and the third columns. Okay. Looks like I'm out of time. I'm just going to finish this example and then make you aware of one other feature. So we're going to start off with the columns Alpha, Bravo, Charlie, Delta. Okay, and they're delimited by a comma. And then I've got a sed that's an extended regular expression. It says starts with a whole bunch of stuff that is, well, some amount of stuff that is not a comma. So that'll match alpha. So alpha goes into capture group 1. And then there's literally a comma. Okay, then a whole bunch of stuff that's not a comma, that's Bravo. And then literally a comma, and then a whole bunch of stuff that's not a comma, that's Charlie. And that's what gets replaced. So Alpha, Bravo, and Charlie get replaced. Okay, what does it get replaced with? Whatever was in capture group 1, so that's Alpha, so you can see that there. And then literally a comma. I have to put both of those back because they're in the part that matches the pattern, so they will get replaced. So the commas get taken out, and Alpha got taken out. And then it's replaced with 3, which is Charlie, and then a comma. And then it's replaced with 2, which was Bravo. And then the rest of the input is not modified, because that didn't match. I didn't put anything here. So that's swapping second and third columns. So I'm out of time, so I'm going to cover one more little thing. All right, so let's say that we have a path that we want to manipulate. Like this. Okay, now I got a little bit of a problem. It's not a big problem, but let's pipe that into sed. And I'm going to tell sed that I want it to do a substitution of forward slashes and replace them with dot for whatever reason, globally. So I got a problem. If I give this to sed, sed is hopefully not going to like it. Yeah, it doesn't like it. The problem is that this forward slash, that's a meta character for the substitution instruction. So I can escape it like that and make it a literal instead of a meta character, and it works just fine. There we go, they all got replaced with dots. But there is a better way. For this one, it's kind of trivial because there's only one forward slash, but when you have more than one of them, this becomes really handy. So sed will allow you to use different meta characters to separate the things that's given to S. So let me go right here. Also for the other commands that take options. This time I'm going to replace it with a pipe. And now I got to deal with the lag. So we got a literal forward slash, and then a pipe, and then a pipe like that. Okay, and then here it works fine. I didn't have to escape this because I wasn't using forward slash as my delimiter for the arguments to S. Instead, I used the pipe, and that meant that this forward slash was a literal. Okay, you could also use something like a comma if you want. So if you have both forward slashes and pipes, you could use comma like this. And that would work fine. So I have had to do this. I had a Windows program. Well, it was a JavaScript program, so it should run anywhere, but it was written by Microsoft, so it was Windows-centric. I was trying to run it on a Unix machine. And it was smart enough to know that the backslash there is a special character on Unix. So it would store its paths, for some bizarre reason, with backslashes instead of forward slashes. But it knew that a backslash needs to be escaped. So it would store this variable that contains a path like this, and then that's how it would store it. But then I use some function to output that, and again it says, oh, backslash, that's a special character. So I have to escape both of those backslashes. So then it became this, 4 backslashes. Was it like that? Yeah, I think it was like that. Or was it forward slashes? Now I can't remember. Let's say it was forward slashes. 1, 2, 3, 4. I don't know why, but this is how, we'll just say this was the case. So that was the thing that I wanted to replace, and I wanted to replace it with a single forward slash. So I could have done this by escaping everything. So escape that guy, escape that guy, escape that guy, escape that guy, and escape that guy. Right? And then all of those are separated, or they're bracketed, by forward slashes that mean meta characters to sed. Then you end up with something that looks like this. And then I guess we'll finish this off. That's a G and that's an S. Right? So you got that monstrosity, and it is absolutely horrid to look at. So instead of that, what I do was I take an S. I'm going to decide I'm going to use the pipe instead of the forward slash as my separator. Got my 1, 2, 3, 4 forward slashes. And then a pipe as a separator, my single forward slash that I want to replace it with, and then the G. So this is much, much more clear. Or even commas if you don't like that we have such tall lines. So let's do that. So an S, comma, 1, 2, 3, 4, comma, 1, comma, G, like that. And that is much easier to figure out what it's doing rather than this thing up here. So that's it. I think that's all you need to be aware of, that you can use different symbols to separate your arguments to the individual commands. Does anybody have any questions?